Hello everyone, this is Mohammed Hashimi Jabr speaking, a master's student in the Faculty of Engineering in the Islamic University of Gaza. Today I am reviewing a paper for the course of selected topics in electrical engineering. The paper is called Optimal Sizing and Location for Off-Grid Hybrid Systems based on economic parameters for solar, diesel, and battery technologies. The paper was published by Elsevier Journal, which has an impact factor of 9. The date of publication was in April 1st, 2020. The names of the authors were Wei Chang, Chang Li, Akbar Maliki, Fathallah Borfayez, Mark Rosen, Hamad Nazari, Du Timbu. These are a couple of Chinese authors, along with one from Iran. Um, Today, we will go through the introduction of the paper, the conflict that they faced, the proposed solution, which is emphasized in the optimization framework. We will see the analysis, and we will go through the discussion and the conclusion of the paper. First, in introduction, we will talk about the topic, the challenge, and the solution they faced. So, the topic was off-grid hybrid energy systems using solar, diesel, and battery technologies. The challenge faced was providing continuous, affordable, and environmentally friendly electricity in rural or remote areas. So they were putting their efforts to provide continuous, affordable, and environmentally friendly electricity in rural areas. The solution was by creating a framework for optimizing both the size and the location of the hybrid system. The conflict, the challenges they faced was divided through three sections. First off, high costs of grid extension, dependence on diesel generators leading to high fuel costs and environmental damage. Solar energy intermittency requires efficient energy storage solutions. Along with that, they had a global issue, which is 1.4 people lack access to electricity, mostly in rural areas or remote regions. So, the paper tried to fix a global issue and faced many challenges as seen, and their current limitation was existing approaches often focus on costs but neglect factors like social, environmental, and reliability impacts. The current solutions, not away from the paper, were neglecting factors like the social factor and the environmental factor. And the authors of the paper came here to come up with a solution to fix the issue they are facing. Okay? So the proposed solution was divided through four goals, in my opinion. There was a technical goal, economical goal, environmental goal, a social goal. But to know how it worked, the hybrid algorithm they used combines simulated annealing and harmony search for optimal results. And the solution they looked for contained from three main components: the photovoltaic panels, the diesel generator, and the battery storage banks. Okay, their goals was a continuous power supply without blackouts, minimizing total life cycle costs, reduce greenhouse gas emissions, improve acceptance for renewable energy systems in rural areas. The optimization framework for that contained from three steps. Step one is to use the geographic information system for optimal site selection. Apply hybrid algorithm for optimal sizing based on technical and economic parameters, minimizing the total life cycle cost to balance initial costs and operational expenses. This framework and this algorithm was done on South Khorasan. Okay, my analysis for the paper. The paper had three benefits through different impacts: environmental impact, in the cost, and the accuracy of the system. First of all, environmental impact: 59.6% reduction in greenhouse gas emissions compared to diesel-only systems. 22.2% reduction in energy supply costs, speaking of cost efficiency. Enhanced accuracy: the hybrid algorithm outperformed other methods by 14.1% in accuracy. So we had like an extraordinary solution that enhanced the accuracy, lowered the costs, and had a very huge environmental impact. So I guess this solution that they came up to is considered a very good solution for the environment, speaking of the accuracy and the cost, of course. The key results: we had two main results. Hybrid systems significantly outperformed diesel-only setups in terms of both costs and environmental impact. Battery and PV systems are critical for handling energy intensity, reducing reliance on diesel. Variations in fuel, initial BV, battery costs, and interest rates were tested. This is speaking of the economic parameters, how they consider that a very good solution, speaking of the costs. The optimal locations was identified using a graphic information system for rural areas in South Khorasan. Now let's discuss and conclude everything we see in the paper. First of all, the paper has many strengths along with many limitations. Okay, I summarize them in three strengths and three limitations. Holistic approach is considering environmental, social, and economic factors was that considered a strength. Real life application via case study because it was done in South Khorasan. Use of advanced algorithm SAHS, which we explained before, for improved accuracy. And we said that the SA stands for simulated annealing and HS stands for harmony search. These are the three main strengths of the paper. The three limitations, I believe, the case study was limited only on South Khorasan. More regions need to be tested, of course. The battery storage technology analysis could be expanded. Dynamic cost changes, as we know that the PV system and the battery costs over time vary through the market, not fully explored. And these are the limitations in my point of view. My conclusion: hybrid systems were effective in providing sustainable energy in remote areas. The framework, novel approaches, optimizes location and size while balancing multiple criteria in the economical, technical, environmental, and social fields. And I believe the future work could be by extending the framework to other regions. As I said in one of my limitations, that it was based only in South Khorasan. Also, refine battery technology analysis for enhanced performance. All in all, the paper main objective was to propose a framework for optimization of grid hybrid systems using PV, diesel, and battery banks. The methodology used was hybrid optimization algorithm combining simulated annealing and harmony search. The results: we had improved cost efficiency and environmental benefits in a real world case study.